For centuries, humanity searched the night sky with a single question in mind. Are we alone? Every new telescope brought us closer to an answer, but none has transformed that search like the James Webb Space Telescope. Designed to study the universe in infrared light, Webb can examine the atmospheres of distant planets with remarkable precision, revealing chemical clues that were once impossible to detect. Among its most fascinating targets is a distant world known as K218b. Located about 120 light-years from Earth in the constellation Leo, this exoplanet circles a cool red dwarf star. Although invisible to the naked eye, it has become one of the most discussed planets in modern astronomy because it lies within its star's habitable zone, the region where temperatures may allow liquid water under the right conditions. When K218b passes in front of its star, a tiny fraction of starlight filters through the planet's atmosphere before reaching the James Webb Space Telescope. That light carries an extraordinary amount of information. By separating the light into its individual wavelengths, scientists can identify specific gases present in the atmosphere. Every molecule leaves a unique spectral signature, allowing researchers to investigate worlds that are trillions of kilometers away without ever leaving Earth. Recent observations revealed the presence of water vapor, carbon dioxide, and methane in the atmosphere of K218b. These discoveries alone attracted worldwide attention. Even more intriguing was a possible signal associated with dimethyl sulfide, or DMS, a molecule that, on Earth, is produced mainly by marine microorganisms. But there is an important scientific distinction. A possible detection is not a confirmation. Astronomers continue to analyze the data because unknown chemical processes on alien planets could potentially produce similar signals without biology. Additional observations will be required before any conclusions can be reached. Even so, the discovery represents a major milestone. For the first time, scientists are studying the atmospheric chemistry of a distant world that could possess conditions favorable for life. Unlike Earth, however, K218b is not believed to be a rocky planet with continents and shallow oceans. Instead, researchers think it may belong to a proposed class known as Hycean planets. These worlds are larger than Earth, surrounded by thick hydrogen-rich atmospheres, and may contain enormous global oceans hidden beneath dense clouds. If this idea proves correct, it could dramatically expand the number of potentially habitable planets throughout our galaxy. K218b is approximately 8 times more massive than Earth and nearly 3 times wider. Despite orbiting much closer to its star than Earth orbits the Sun, the planet receives a comparable amount of energy because its host star is much cooler and dimmer. That balance may allow temperatures capable of supporting liquid water beneath the atmosphere. Scientists believe the thick hydrogen envelope could act like an insulating blanket, trapping heat and helping maintain relatively stable conditions over long periods. This makes K218b an extraordinary natural laboratory for understanding planetary evolution. For decades, researchers focused primarily on finding worlds that closely resembled Earth. Now, Webb is showing that nature may have created many different pathways toward habitability. Instead of searching for an exact copy of our planet, astronomers are beginning to investigate an incredible diversity of environments where chemistry, water, and energy might come together in unexpected ways. Every new observation reminds us that the universe is far more imaginative than we once believed. If K218b truly belongs to the proposed class of Hycean planets, then it represents a completely different kind of world from anything found in our solar system. Imagine a planet where there are no familiar continents, no deserts, and perhaps no mountain ranges rising above the surface. Instead, beneath a thick blanket of hydrogen-rich clouds could lie a vast global ocean stretching across the entire planet. Such an environment would be unlike Earth, yet it might still provide the basic ingredients needed for complex chemistry. Scientists believe that if a deep ocean exists beneath the atmosphere, it could remain stable for billions of years. During that time, water, dissolved minerals, and internal heat might interact continuously, creating conditions where interesting chemical reactions could occur. Whether those reactions could eventually lead to life remains one of astronomy's greatest unanswered questions. Life on Earth has repeatedly demonstrated an incredible ability to survive in extreme environments. Microorganisms have been discovered around deep-sea hydrothermal vents where sunlight never reaches. Others thrive beneath Antarctic ice, inside highly acidic lakes, and in environments once thought completely uninhabitable. These discoveries have transformed our understanding of biology. They suggest that life does not necessarily require Earth-like conditions. Instead, it may simply require the right combination of liquid water, available energy, and enough time for chemistry to become increasingly complex. That possibility makes planets like K2-18b especially exciting. Rather than searching only for rocky planets almost identical to Earth, astronomers are now exploring a much wider range of environments that could potentially support biological processes. One of the most important goals of the James Webb Space Telescope is the search for biosignatures, chemical clues that might indicate biological activity. However, scientists approach this search with great caution. A single molecule is never enough to claim the discovery of alien life. Every possible signal must be tested against natural geological and atmospheric processes that could produce similar results without biology. That is exactly why K2-18b continues to receive so much scientific attention. Future observations will measure its atmosphere with even greater precision, helping researchers determine whether the reported chemical signatures remain consistent over time. Additional space telescopes and future observatories may eventually provide even clearer answers. Whether the final explanation turns out to be biological or entirely geological, K2-18b has already changed planetary science. It has expanded humanity's definition of what a potentially habitable world might look like. For generations, scientists searched for planets that closely resembled our own. Now, evidence suggests that the galaxy may contain many different types of worlds capable of maintaining stable environments for billions of years. Considering that red dwarf stars are the most common type of star in the Milky Way, the number of planets similar to K2-18b could be enormous. Some may possess deep oceans. Others may have entirely different atmospheric chemistry. And some could reveal planetary environments unlike anything we have ever imagined. The James Webb Space Telescope has not confirmed extraterrestrial life. But it has brought us closer than ever before to answering one of humanity's oldest questions. Every observation pushes the boundaries of science. Every spectrum reveals another clue. Every distant world reminds us that our solar system is only one small part of a galaxy filled with countless possibilities. Perhaps somewhere among those distant oceans, beneath unfamiliar skies, around stars that glow far more dimly than our sun, life has already found a way to exist. Until future discoveries provide the answer, K2-18b remains one of the most fascinating destinations in modern astronomy, a world encouraging humanity to keep exploring, keep questioning, and keep looking deeper into the universe.